Next we have the function secant of 4x cubed plus 1. So since it's not just secant x, it's secant something else, we will use the chain rule and we'll take the derivative of secant u. So the derivative for secant u is secant u tan u times u prime. So here the derivative is secant u tan u times the derivative of the u. The derivative of 4x cubed plus 1 is 12x squared. And then we can just rewrite it with 12x squared in the front. So the derivative is 12x squared secant of 4x cubed plus 1 times tangent of 4x cubed plus 1. Next we have the function cosecant cubed of 9x plus 2. So when the power is in between the trig function and its argument, you can rewrite it as cosecant of 9x plus 2 all cubed. So here I can see the outer function is power 3. So we'll be taking the derivative of u cubed, which will be 3u squared times u prime. So the derivative will be the 3 copy of the u squared. Now we want to multiply by the derivative of u, which is itself a composition. So cosecant of 9x plus 2 we'll be taking the derivative of cosecant u, which will be minus cosecant u cotangent u prime. So we'll multiply by minus cosecant 9x plus 2 times cotangent 9x plus 2, and the derivative of 9x plus 2 is 9. So 3 times minus 9 will be minus 27, and we can combine the cosecant terms into cosecant cubed of 9x plus 2, which is multiplied by cotangent of 9x plus 2. So that's the derivative. Next we have the function, the fifth root of x tan x. So we can rewrite this as x tan x to the power 1 over 5. So here, since we don't just have x to the power 1/5, we have x tan x to the power 1/5, then we can use the chain rule with u to the 1/5. So the derivative of u to the 1/5 is 1/5 u to the minus 4/5 times u prime. So the derivative is 1/5 x tan x to the power minus 4/5. Next we want to multiply by u prime, so we want to take the derivative of x tan x. X tan x is a product, so when we take the derivative, we'll use the product rule. So here we use the product rule, we copy the x, and then take the derivative of tan x, which is secant squared x. Next we copy tan x, and take the derivative of x, which is 1. And if you want, you can put it back in the radical notation. The power of x tan x is negative, so it will go in the denominator. And x tan x is to power 4 and fifth rooted. Next we have the function square root of sine of square root x. So here we can rewrite the square roots with power half. We have sine of x to the half, all to power half. So here we see the outer function is the power half. So we will use the chain rule with u to the half. The derivative of u to the half is 1/2 u to the minus half times u prime. So when we take the derivative, we'll have 1/2 u to the minus half. Now we can take the derivative of the u, which is itself a composition. It's sine u, and the derivative is cosine u prime. So we'll multiply by cosine of x to the half times the derivative of x to the half, which is 1/2 x to the minus half. And 1/2 times 1/2 will be 1/4. Cosine x to the half will stay in the top as cosine of root x. And both x and sine root x are to power minus 1/2, so they will be square rooted in the denominator. The following problem is about surge functions. Surge functions can be used to model the concentration of medication in a patient's bloodstream. Surge functions have the form s of t is equal to at e to the minus kt for positive constants a and k. If the concentration of a medication in a patient's bloodstream is given by the surge function c of t is equal to 5t e to the minus 0.25t in milligrams, where t is in hours since the medication was administered. Find the times when c prime of t is equal to 0 and c double prime of t is equal to 0. So we'll take the first derivative of c. 5t is multiplying e to the negative 0.25t. And since it's a product, we will use the product rule when we take the derivative. Also, since we don't just have e to the t, we have e to the minus 0.25t, we will have to use the chain rule when we take the derivative of the exponential function. So for c prime of t, we have a copy of the first, 5t. Then we have the derivative of e to the u, which is e to the u times u prime. So e to the u prime is e to the negative 0.25t times the derivative of negative 0.25t, which is negative 0.25. Then we have a copy of e to the negative 0.25t and the derivative of 5t, which is 5. We can take out the common factors. 5e to the negative 0.25t. We'll factor it in the front. After we factor, we are left with negative 0.25t plus 1 in the big bracket. So we want to know when the derivative is equal to 0. So we can use the zero product property with each of the factors. The first factor, 5e to the negative 0.25t, is never 0, since the exponential function is never 0. So the derivative will only be 0 when the second term is equal to 0. So we can set negative 0.25t plus 1 equal to 0 and solve for t. We'll bring 1 to the other side as minus 1, and then we can divide both sides by negative 0.25. So c prime is equal to 0 when t is equal to 4 hours. For the second derivative, we'll take the derivative of c prime. Here again we have a product, so we will use product rule, and when we take the derivative of e to the negative 0.25t, again we'll be using the chain rule. So for the product rule, we'll copy the first term, then we take the derivative of the second term, which will just be negative 0.25. Then we'll copy the second term and take the derivative of the first term, and we can use the chain rule for e to the u. It will be e to the u prime. So 5 times e to the negative 0.25t times negative 0.25. Next, we'll factor out the common factors in the front. So from both terms, we can take out 5 times negative 0.25 times e to the negative 0.25t. After we factor those out, we'll have 1 plus negative 0.25t plus 1 left in the big bracket. We want to know when the second derivative is equal to 0, so that will be when either of these factors is 0. But again, the exponential function is never 0, so c double prime will be equal to 0 when 2 minus 0.25t is equal to 0. So we can bring the 2 to the other side as minus 2, and then we'll divide both sides by negative 0.25. So t will be equal to minus 2 divided by negative 0.25. So the second derivative is equal to 0 when t is equal to 8 hours. Here's a graph of the surge function. From the graph, we can see that at t is equal to 4, the concentration is a maximum at the point M. And also at t is equal to 8, the concentration starts to level off at point D. Later we will call this point an inflection point. Surge functions can help to predict when the maximum concentration will occur, and also when the patient will need a second dose.